Problem 121 Quantum Mechanics. The question is, consider the operator AX equal to Lypz minus Lzpy, where Li and Pi denote respectively the components of the angular momentum and momentum operators. The commutator of Ax and x, where x is the x component of the position operator, is. In the present problem, we have to evaluate the commutator of Ax and x, where Ax is equal to Lypz minus Lzpy. It is given that Ax is equal to Lypz minus Lzpy. We have to evaluate the commutator of Ax and x, where x is the x component of the position operator. The commutator becomes the commutator of Lypz minus Lzpy and x. This is equal to the commutator of Lypz and x minus the commutator of Lzpy and x. Now let us use the standard relation, the commutator of A, B and C. And using that relation, we can see that our commutator is the commutator of Ly and x, Pz plus Ly, the commutator of Pz and x minus within bracket the commutator of Lz and x Py plus Lz times the commutator of Py and x. Now we have the commutator of xi pj is equal to ih bar delta ij. Therefore, the commutator of pz and x is equal to 0, and also the commutator of py and x is also 0. Therefore, the answer is the commutator of ly and x pz minus the commutator of lz and x py. Now let us substitute the values of ly and lz. Ly is z px minus x pz. Therefore, the commutator becomes the commutator of z px minus x pz and x pz minus the commutator of x py minus y px and x py. Now let us expand the commutator. The commutator of x px and x minus the commutator of x pz and x, close the bracket, pz minus within bracket the commutator of xpy and x minus the commutator of ypx and x, then py. Now we can see that the second term and the third term vanish because the second term contains the commutator combination of x and pz, which is 0, and the third term contains the commutator combination of x and py, which is also equal to 0. Therefore, our commutator becomes the commutator of z px and x pz plus the commutator of y px and x py. Let us expand the commutator as the commutator of z and x px plus z, the commutator of px and x pz plus the commutator of y and x px plus the commutator of y plus y times the commutator of px and x, then py. The commutator of z and x is 0, the commutator of y and x is also 0. Therefore, our commutator becomes z times the commutator of px and x pz plus y times the commutator of px and x py. We have x px is equal to ih bar, the commutator of x and px is equal to ih bar. Therefore, our commutator becomes z times minus ih bar pz plus y times minus ih bar py, and this is equal to minus ih bar z pz plus y py. That is, the commutator of ax and x equal to minus ih bar z pz plus y py. Hence, from the given option, we can say that option A is the right option.